Bine v-am regăsit la PoliTech! Sunt Alexandra Marian și începem împreună o nouă ediție. Timișoara a fost gazda celei mai importante conferințe din România dedicată tehnologiei. Aproape 1000 de persoane au venit să-i vadă pe unii dintre cei mai mari specialiști din lume în domenii precum computația cuantică sau industria aerospațială. Printre cei mai renumiți oameni de știință prezenți la Tech Talks 2025 s-au numărat Gregory Robinson, cercetător cu o carieră prodigioasă la NASA de peste 30 de ani, în care a coordonat peste 100 de misiuni științifice, sau Brandon Berry, inginer cu o vastă experiență în cercetare și dezvoltare de soluții bazate pe inteligență artificială și tehnologii de viziune computerizată. Supremația Quantum, topicul ediției de anul acesta a conferinței de tehnologie organizată de Universitatea Politehnică Timișoara, Tech Talks, a adus pe scena de la Timișoara oameni de știință de referință în lumea contemporană, cum a fost Gregory Robinson, cercetător care a coordonat peste 100 de misiuni științifice la NASA. Una dintre cele mai celebre a fost misiunea telescopului James Webb, care de la lansarea lui în spațiu în 2021 a colectat date despre zeci de galaxii aflate la milioane de ani lumină.
So a few weeks ago, I think it was mid-April, this story ran in many outlets across the globe. This is a planet in a nearby galaxy, 124, 125 light years away, if you call that nearby. And we believe there are life signatures there. And that's a real big finding when you're talking astrophysics. The two big questions, where did we come from? What's our place in this vast universe? And the age-old question, are we alone? So this gets us closer to that second question, are we alone? So how did we get here? In 2017, Webb was in the later stages of development, but couldn't really seem to get finished and get to the launch site. So my boss asked me to take over in early 2018. I declined many times. At some point, I reluctantly agreed after he twisted both my arms. And just a little bit on Webb, you can see up top here the big mirror, which I'll talk more about in just a minute. That's actually 18 separate mirrors to make up one, and we'll talk more about that in just a second. You see in the middle that sun shield, the horizontal piece, and on the bottom is the spacecraft, the bus, the brains and electronics. We have to keep that top side very cold, always pointing to deep, dark, cold space. And we want to keep the electronics nice and toasty. That sun shield helps us keep one side very cold, one side very toasty, almost 600 degrees difference. If you could imagine that, you go from one wall in your house to the next wall, and the 600 degrees difference. A lot of engineering had to go into making that possible. Many of you are familiar with Hubble, 35 or so years on orbit. Hubble is in low Earth orbit, 250 miles above the Earth. We were still flying the space shuttle. We launched Hubble with some flaws, and we had 5 service missions with astronauts when we were still flying the shuttle. We knew in the case of Webb, we would not have shuttle. We would not have any human capability to go do servicing. Also, we're a million miles away, so we didn't plan for servicing. And you can see the size of the mirror, 2.4 meters for Hubble, a monolithic mirror. And Webb, again, it's 18 segmented mirrors, 6.5 meters, which is quite big. It fill up this room here. And Hubble is about the size of a school bus, and Webb is about the size of a tennis court. It's a huge, huge difference in size. With the big difference in size, Webb is almost half the mass of Hubble. So a lot of ingenuity went into making that possible. This is that sun shield I talked about. There are 5 different layers to this sun shield. They have to deploy autonomously in space. Each layer, that's a new technology as well, never been developed or flown before. The membrane nor the system, about the thickness of a hair on your head. Each one of those, we have to fold it up, deploy it in space, and again, there's no help on the way. So here's some other technologies. We had 10 new technologies on Webb, never been developed or flown before. When you talk to the instrument providers, the scientists, they'll tell you it's a lot more than that because all of them have a lot of new technologies in their instruments, which is true. But these are the ones we normally talk about. The backplane technology, the way we machined beryllium really kept that steadiness in Webb. It's pretty important when you're pointing and staring at something. We talked about the sun shield, the cryo coolers were pretty important to that, and the list goes on, the ASICs, the micro shutters, and so on.
Gregory Robinson a coordonat mii de teste de vibrații, de rezistență fizică sau la zgomot, toate pentru a se asigura că James Webb va fi capabil să reziste în spațiu. Telescopul a fost dezvoltat în 29 dintre statele care formează Statele Unite ale Americii și în alte 14 țări.
People are working pretty fast. I wish I could have gotten them to work this fast for development. Would have been done a long time ago. We're doing the integration now of the two halves. You can see access was pretty challenging. We have cherry pickers, we have diving boards to get access. Very complex. Deploying the sun shield here. It took us 3 months to do that integration, which lets you know how complex it is. And during that time, we did everything right, the right way. That wasn't always the case. So again, very complex, very delicate. Little things really hurt, and there were quite a few little things that hurt us during the development before then. And at the time when I took over, we were spending, our burn rate was $1.5 million per day. That's a lot of money. And I took over in March of 2018. The bottom half of that, the spacecraft and the sun shield, we took it to environmental testing. We did acoustics testing. And going from the acoustics chamber to the vibration chamber, you always do an inspection. And we found fasteners all over the floor. And that's a bad day. And that was 6 weeks after I took over. So I was still in my honeymoon period, thank goodness. Otherwise, I probably would have been in another country by now. By choice or not, I don't know. That cost us 8.5 months to get that right. Now, some of that work was done in parallel, some of it was in series. But even before that, we had some major problems. So I had to go to the White House and to the Congress and ask for $800 million to complete Webb. Again, I was still in honeymoon. Some people said I was the savior. I always think of Jesus as the savior, but that's another whole story. But they gave us $800 million. One of the reasons we had a world-class review team with many scientists that said completing Webb was really an imperative if the U.S. wanted to stay in the leadership for astrophysics. And so they gave us extra money. I had to re-baseline. I told the team their schedules and costs were not real, so we had to redo that before I went out to ask for more money. And I said I would retire before I asked for another penny. Didn't know COVID was coming, by the way, so COVID came a little bit later, and that cost us about 3 months of direct impact to schedule, plus the time to really get back up to speed. But we never had to ask for another penny to get Webb done. This is the final integration at the launch site. We integrate, process the spacecraft in one building, the launch vehicle in another building because of all the hazards with the launch vehicle. Then we integrate them. See, rockets are pretty big for the ones who haven't been around them. You can see the people in the clean room suits. Those are different suits because of the hazardous environment. You see the clean tent around it. Keep those mirrors pristine. This is final integration. Putting the fairing on for the only time. It actually hung up when we got about 2 or 3 inches from completion. Cost us a few hours. This is December 23rd, rolling out to the pad at the beginning of rainy season.
Engine start. And
Allumage
liftoff.
UAP, décollage.
Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
We just separated from the rocket. So we're looking at the bottom of the satellite going away from us. This is real imagery.
În opinia exprimată de Gregory Robinson la Tech Talks 2025 cu privire la focusul studenților pentru viitor, când inteligența artificială va fi peste tot, acesta a apreciat că ar trebui să existe abilitățile necesare pentru ca ei să-și dea seama dacă ceea ce spune robotul este real. Informațiile fundamentale trebuie învățate. Un alt invitat de talie mondială de la Tech Talks 2025, organizat de Universitatea PoliTechnică Timișoara, a fost Brendan Berry, inginer cu o vastă experiență în cercetare și dezvoltare de soluții bazate pe inteligență artificială și tehnologii de viziune computerizată.
So I'll try and introduce quantum bit by bit and just build up the story. So quantum computing was really initiated by Richard Feynman back in 1981. In my lifetime, at least, this is relatively recent. And he asked the question, how small can we go? How small can we make a transistor? Can we make it as small as an atom? And can we use an atom to do a calculation? And at the same time, he was trying to do quantum mechanical simulations. He was trying to figure out what is the right way to do this. And he reached the conclusion that really we need a quantum computer to simulate quantum mechanical. And this opened up a whole new thought process that evolved into what is the quantum industry today. People often ask, when you have a quantum computer, what can I do with it? What classical computer will it replace? And it's quite difficult to answer that question. And this slide is to try and impart exactly the value or why are we so interested in quantum and why is everyone chasing this to really believe that it is the actual next step that we need to go to. And it's really the exponential power of quantum computing. And this statement at the bottom, every time you add a qubit, you double the processing power. I should say roughly double. And it also assumes that the qubits are perfect and that you can perfectly entangle all of them, which is not true in reality. But nevertheless, it gets the message across that every time you add a qubit, it increases or doubles the size exponentially. And then you get asked the question, well, exactly how much processing is in a quantum computer? And that's actually also quite hard to answer. Maybe the first part of that question is quantum computers will not replace classical computers. They're not a direct comparison. They will only work for certain defined applications that are quite specific for quantum. So we will see quantum computers turn up as accelerators with classical computers. Classical computers will always be there. The quantum computers will be used to do certain tasks they're particularly good at. Just to give you some flavor of how much processing you can do, the Fugato supercomputer, the guys in Japan attempted to faithfully simulate qubits, and they said, well, how far can we go? And at the time when the Fugato supercomputer was #1 in the world, they got up to 45 qubits, and they could see how they could get to 55 qubits using the full capacity of the supercomputer. And they noticed that, of course, every time they added a qubit, they needed to double the memory of the supercomputer every single time. And they concluded, okay, the theoretical limit based on memory usage of our supercomputer is 55 qubits, and we think we've answered the question. Now, they're not exactly equivalent, but it gives you an idea of the class. If we had 55 perfect qubits that we can fully entangle, we would be able to do some calculations of the class of a high-performance supercomputer. This is where equal one comes in. We have pulled many of these pieces together to build a 6-qubit quantum computer, which we also showed at APS. And this is everything self-contained. You plug it in a wall. There's no changing to your infrastructure. You plug any regular IT room, 1.6 kilowatts, so no more power than your hairdryer. And you can leave it running continuously, no maintenance needed. And we can do rudimentary quantum chemistry simulations on a 6-qubit device. But what's more intriguing about this is we can upgrade it the same way you upgrade your CPU back maybe in earlier days, you would take out a CPU out of your computer, put in the new generation CPU, and you get an instant upgrade. We will do the exact same. We can upgrade this near term to 17 qubits, and then somewhere in the middle of the next year to 3-digit qubits.
Oamenii nu ar trebui să se sperie de tehnologia quantum, este de părere Brandon Berry. Acesta estimează că în 15-20 de ani aceasta va fi văzută ca ceva normal. Timișoara, prin Universitatea PoliTechnica, are un cuvânt de spus și prin masterul de quantum computing pe care îl organizează.
The city has been helping us get set up and getting the startup culture, I guess, and the environment for getting the engineers and scientists together. The interaction with the PoliTechnic has been really, really useful, and they've been very helpful and supportive of getting the right skills that we need to be able to hire the right people here and really let us scale up.
PoliTechnica University is one of the few universities in this country that has a program preparing students in quantum computing.
Yes, there's very few universities that do this, even around the world. But we're very supportive of introducing the quantum mechanics master's program for non-physics graduates, so that they can learn about quantum engineering and quantum mechanics and apply that into building a quantum computer. And that's been very instrumental in getting the right skill sets and getting the right knowledge into the people. And it's been extremely helpful. We're seeing the interns and the graduates beginning to come out now, and that's really, when they start working for us, they've already got a very good skill level and basic knowledge that we can build on and hopefully harness to build a really big team here ultimately.
TechTalks by UPT va avea loc și în 2026. Tema conferinței de tehnologie de anul viitor va fi de neînlocuit. Viitorul are nevoie de oameni. Dragilor, acesta a fost PoliTech de astăzi. Eu sunt Alexandra Marian și vă aștept și săptămâna viitoare.